Hello, welcome back to our CSCI 340 database. And for today's lecture, we will move on to a new chapter. It's about the physical database design, how we actually design it, and we try to describe the concept of like physical database. Like how can we design? Okay, how can this device works? Okay, actually it works, and also the principle of the file organization, and then the access methods. Okay, so this we're going to cover. Is a pretty long chapter, and then we talk about the index. Okay, so when we try to retrieve the data, what's the two different searching method? Like for indexing, so one is a simple linear, and then the people's tree. Okay, and also how those like hash the file works. Okay, and then the last, how can we least describe the input to the physical database design process? So and then so far we will try to perform some physical database design and improve the database performance using a variety of like techniques ranging from like adding index to denormalization. So all these we're going to cover. And it's a pretty long chapter, so we will like break down, cover in the coming few lectures, okay. And so far, if we think about design a database, we ask the performance. Okay, so what are the possible factors that are going to affect the application or the database performance? Of course, including the in the application level, like this factor. So we need to join tables, okay? And all these like joining, I think in practical, most of you already try to join at least two tables to get together, three tables. Okay, sometimes okay, the situation we have to joining three or even more than that, four or five. Okay, and sometimes we need to calculate the totals. Okay, sum, adding value, counting average, whatever. Okay, all those like mathematical. So all these will affect the performance. And most normal, like because for database we talk about data itself, like we have a data volume is really large amount, even huge. Okay, if for daily like transaction business, okay, the the data like goes up by rapidly, so it's really hard to mention. Okay, then how can we have a better design? Okay, and then the next, the database and structure factor. Okay, so do we have a direct access? If we lack of it, then we cause a problem. Also, so like the clumsy primary keys. Okay, so how can we design the primary key? So that's why working with indexing and then the primary key. So instead of the combination keys, we prefer to using the some like numbers. Okay, numeric, and then try to create another primary key. So here's the reason why. Okay, so we're doing this way. And then also so because the like the data storage factor, okay, some related like data displayed like on disk. Okay, of course, maybe we now improve a little bit. Okay, so maybe we have some like business environment factors. So that one is mainly the data access operations. Okay, so maybe just too many. Okay, we need to keep on read, write, or read, write altogether. Okay, or the overly like liberal data access, all this will affect the database performance. So you need to know. And so far, when we need to do the like physical database design, so we need to think it's a process like modifying the database structure that to improve the performance of the like runtime environment. How can we retrieve the data faster immediately? Okay, so we cannot waiting for a minute and then return the data, right? So how can we going to modify like is that the third number form tables? Okay, so produced by the logical database design technique. So how can we make it like runs faster, like use it better? Okay, and just as like we kept what we talked about was the first number form, second number form, and third number form, right? So remember, so like all the row or the attributes, okay, so we only have one values, okay, and then we need to like, make sure they have the with the functionality, okay, so direct, okay, and so their dependency, okay, so all this make sure we clear all this become a third number form. And we talk about the disk storage, we do have like the main memory, or sometimes we call it the primary memory. So it's the RAM, right? So where the computers execute the programs or process data. So this one is way faster. And then it just is a permitted direct access to the database. But it has some several like drawbacks. Okay. So it's a relatively expensive, even though we say expensive, even the price is kind of fluctuated. Okay, so also it's not like transportable. Okay, and it's a volatile. Okay, so it's like once we power off, so none of them being safe. Okay, so here's the concern. um then, or we talk about the secondary memory, so we will like store all those say data on there. Okay, in old school a long time ago, we do have the hard drive. Okay, so it's way slower than the SSD. Or right now we talk about the like M2. Okay, so they're different, but all these like they can save like permanently. Okay, and then when we load the data from the secondary memory into the primary memory, that means I'm loading from the, maybe we say, but nowadays using SSD, loading from SSD to the RAM, it also still needs some time to process. Okay, so we still need to know like when we transfer. Okay, and how can we transfer from the first um the secondary to the primary or main memory. Okay, so here's the concept right here. So when we have a box, and then we need to like get that book and then open it, and then we can read it. So here's the idea. So when a person needs to some particular information, okay, that's not in his or her brain at the moment, then she needs to find a book in the library. So we need to search the library, we how can find it, then we can transfer those information from the book to into the brain. Okay, so it's the idea. Then how actually, okay, the disk storage work. Okay, so the disk they come in the variety of the types. Okay, capacities. So including like multiples or aluminum, or let's say make this unit. This a long time ago. Of course, we do have some like removable. Okay, external hard drive too. Okay, and all these provide direct access capability to the data. Okay, so when we say direct access will be the hard drive. Okay, the storage, so directly access it to it. This one is H the HSD, we call the hard drive. Okay, so like say for these type printers, they're stacked together and then mount on the center. Okay, spindle, and then when there's some space between them, so there's a needle right here. So when they like rotate, they read it. Okay, at the same time. So there's like we call the disk. Okay, of nowadays, we are not using. I would say this one is like fading out. Okay, maybe for some situation we are still using this kind of disk, but most of the time we already upgrade to the SSD. Okay, solid state disk, right? So it provides faster, more stable. Because like for all these like physical access, so they have a pin right here within. So when it's like rotation, and if there's some vibration, or like maybe it drops, or I don't know, any situation, any like physically they cause a physical damage, then you will lose the data. Okay, so that's why it's not that safe enough. And right here, the plater, if you know, they have a magnetic coating, so they can then magnetize, and then that's how it like data is stored, like bit by bit. Okay, here's the kind of idea you can see. And because when we have the SS arm right here, the mechanism you can read in the read write heads right here. So you can read in the both times. So the recording surface, so you can read in the both side, right? Okay, up and down. So all this you can read. So all this with the amplifier. So right here, the basic display drive has one SS arm mechanism. We say is the arms that can like reach in between the discs, and then at the end of each arm they have like two reading head. Okay, right here. So this video, once the spin, then altogether there is a single unit. So at the central window, okay, so at a high velocity, so it's a really spin high. That's what we say is the access of the like old hard drive. Okay, and inside the jack, so there called something called the tracks. Okay, so it like is concentric circles. Okay, so which data they store. Okay, so there's really serially by bit. Okay, all this like we have the 301, 2, and then it goes in. Okay, so all this when they're rotating. So just keep going. And then so far we put them all together, then we call it a cylinder. Okay, so it's like collection of the track. Okay, so one of like each day recording surface, so they're one like directly above the other. So it's like correct. So when we say the number of cylinder in a disc, that means like the number of like the tracks. Okay, so on any of its like recording surface, so all this I would call it the cylinders. Okay, right here. Well, when we looking it's more like in 3D, so it's like the vertical way. Okay, so we have again look it like from the top view or bottom view look into it, so it becomes a cylinder. And all these like maybe we were saving the track like 76, for example, right here. So of the recording surface. So we have the surface like 0, 1, 2. Okay. And the collection of this like the surface like try to say we talk about 76, right? So one above the others, and then seems to take the shape of a cylinder. That's like we call it. So it's a collection of tracks. So it's in the 76. You may be asking, okay, why do I need to know what's the cylinder? Nowadays, okay, we are still using the hard drive. Okay, so you still need to know it. So once we have like established cylinder, then it's also necessary to number the track. Okay, within the cylinder. Okay, so which track? Okay, track 1, 2, 0, 1, 2 right here going up. So cylinder is showing like 76 track. Okay, and so far if we need to find or transfer data, so what the steps? First, we talk about the seek time. Okay, the seeking. Okay, how can we takes like the time like to move the SS arm mechanics, some like to the correct cylinder, and then from the wherever the cylinder is at current position. So we have to like really look and move it. And then the head switching. So we need to set the right head to access the required track on the cylinder, right? So you know the track. So we have the track. Okay, so track 0, 1, 2, and then if you remember track, and then we have the vertical looking as a cylinder. Okay, so right here, and then what's the rotational delay? Because like we need to wait for desired data on the track. Okay, to arrive. Okay, under the read write head. So it's this is spinning, right? So we is a spinning. So how can we wait for it? So we need to know the rotational state delay. Okay, so there's a little bit, and then the transfer time. So the time actually we need to move the data from the disk to primary memory. So once the previous 3 steps have been like complete. So once like we able to see it, okay, and then once the head switch it and then rotation, okay, arrive, and then later we able to transfer it from the secondary to the primary memory. Okay, so it's the steps. And about the file organization, or how can we access? So for the file organization, the way that we say is that we store the data for the subsequent retrievals, okay? And then possible access method will be the way we retrieve the data, okay? So it will be based on the how it's being stored in a particular file organization. So if we save in those file organization, then we maybe have those access method. Okay, we say so. Here's called the file organization and access method. Is a definition. And when we need to achieving the direct access, so we need to an index to. Okay, so or we need to have a hashing method. So we need to have a way to store and also retrieve the records, right? So let's say if we know the value of a field, okay, of a record. So if we want to retrieve, then what's the index or the hashing method will be like pinpoint its location in the file, so we know where we can access it directly. Okay, so it instructs the hardware mechanism of this device where they to find it, so we know where it being stored. Okay, where we saving those data, then we can access it faster. Okay, so for the index right here, will be the principle, like same as like the governance, the like index in the book, like back of the book, we're telling you, okay, if I want to find something, so go to which page. Okay, so we have the store all the index, right? So the index is the items of the interest they're like copy over into the index. But the original text they're not distributed in any way. Okay, so the items in index they are still short. Okay, so each item in the index is associated with a pointer. Okay, so this like the pointer pointing to it. So if you learn data structure, okay, so you know no matter which way of the storage, okay, for searching, okay, the perfect, the best way is the time the big O is the N or N, right? So this will we wanted to access for like retrieving, okay. And then the most like basic one, so will be the simple linear index. So what's this one? Like, if you remember, if we have a table, we have a sales names or some like record address, record numbers, or like right here, right? So we have sales name, numbers right here, city. Okay, in this file, so we will create an index. Okay, so this one including what's the sales name. Okay, also the record address. Okay, so which one? So right here, the salesperson file right here, you know, with an index that built over the salesperson name field. Okay, so this index is like ordered by the salesperson name. Okay, so they're in ascending order. So A, B, C, D, like this, keep going. And then first index record showing, okay, Adam 3. Okay, because the record right here. So there's like the salesperson file, right? So with the salesperson Adam, so it's the relative like record location 3 in the salesperson file. Okay, Adam's right here. So 0.3, and then Baker is 2. Okay, right here, and then 6. Okay, 7. Green. Okay, right here. So it's a simple linear index. Or you can see another example. Let's say we have the city. If we index it by the city field, and we will show, okay, if we need to show a lantern, so we'll go to like 5. Okay, so here's the idea. So they build on like over a field have a non-unique values. So if an index builds, okay, so you see because you can see right here we have the dollars. Okay, we go to 3 and then dollars 4. Okay, sequential. So it can be. And then also one is like, let's say if we using the salesperson number field. Okay, so if we using the salesperson number, and then we create, so this one is the index like sequential file. So all these file they are store okay on the this in the order based on the set field value. Okay, let's say the salesperson number right here. So and then index that build over the same field. So it's like pointing. The benefits is like when we access mainly using the salesperson number. Okay, so maybe we using as a foreign key, primary key, right? For it pointing to it, then it would be better. Okay, so it's we know like have a double access. Okay, the database and management system, okay, and it helps that, or like we are not really handle with the physical, the hardware mechanism, okay, how we really access, but at least like through building the index, they will know, okay, which track or like in the cylinder, so they will need should go to retrieve the data. And then let's say if we have a new item going to be inserted, okay, let's say right here, when we insert a new row, it always go to the last row, right? The last one. So if right here, when we insert a record, let's say there's like 452 fans right here, but how can we squeeze the index record into the proper sequence? So we will ask a question, because right here, you know, we have the salesperson name, and then if we have the index right going down, so we will short it in the order, ascending order. So we like French point right here. Then what should we do? Okay, so right here we need to insert between the records, like right the green and then the green, and to maintain the crucial alphabet sequence, right? So but we have to move all index record. Okay, so all of them they move down. Okay, one the record position. Then do you think is a good solution for index record of a file? probably you didn't say no way. So then we need to have another way of index. And this one we will going to cover in the next lecture. And thank you so much.